unit rates and complex fractions. All right, so this is unit rates, complex fractions from Florida Virtual Module 4.01. So this is going to mirror some of the problems that you're seeing on this first week's module. And the first week is talking about ratios that compare two quantities with different kinds of units that are called and these are called a rate. So when a rate is simplified so that it has a denominator of 1 unit, it is called a UR. Well, that's going to be a unit rate. And if you want to go over the R up there, you can. And a complex fraction are fractions with a numerator, denominator, or both that are also fractions. And a complex fraction or complex fractions are simplified when both the numerator and denominator are in I. Well, that I word, remember from class, is an integer. Remember, those are positive whole numbers and their opposites, and 0. So I'm going to use notebook paper to work out these problems, and you can follow along, take notes. The first practice problem, it says an assistant cook peeled 18 potatoes in 6 minutes. At this rate, how many potatoes can he peel in 50 minutes? So we're going to start by taking this rate and writing that ratio. So when we're looking at this ratio, we're looking at the number of potatoes over minutes. All right, so here's our ratio, and we'll just label that problem number 1. So we know that he can peel 18 potatoes in 6 minutes. Then we want to take this down to a unit rate. Remember, that's when our denominator is 1. So to get to 1, I divide by 6. 18 divided by 6 is 3. And then from here, we want to know how many potatoes he can peel in 50 minutes. So minutes is our denominator, so we're going to put 50. And we got to figure out what is that numerator. So again, what is the factor we're multiplying by? And here, this is times 50. So we're going to do the same thing to our numerator. 3 times 50 is 150. Which means he can peel 150 potatoes in 50 minutes. Number 2. It says a construction worker is blacktopping a driveway. That means they are putting down that tar on a driveway, just like a road. She blacktops 35½ square yards in 5/6 of an hour. How many square yards can she blacktop per hour? So again, another hint here, potatoes per minute. Well, we're looking at square yards per hour. So when we set this one up, let me just move this up. Give myself a little space on the paper, fold it down. And let's solve this one. So let's set up this proportion, or this rate here. Our ratio is square yards per hour. Remember that fraction bar is also a division sign. So when we're setting this up, we know she can blacktop 35 and 1/2 over 5/6 and 5/6 of an hour. So this is called a complex fraction. And what we want to do is, let's rewrite this complex fraction as a division problem. So we're just going to take that 35 and 1/2, and we're going to say we're dividing by 5/6. So we're going to rewrite the problem. Now from here, we can't divide yet. We can't even do our KCF or keep, switch, flip, whichever way you prefer to refer it to as. So the first thing we need to do here is now rewrite that mixed number into an improper fraction. So we're going to take this 35 and 1/2, and we want to multiply and then add. So 2 times 35 is 70, plus the 1 is 71 over 2. So you want to convert the mixed number to an improper fraction. Number 3, so some of the students say KCF, some say KFC, and then others use the phrase, I think, stay, switch, flip, meaning we're going to change this to a multiplication problem. So we're going to keep that first fraction, change it to multiplication, and flip that fraction over to 6/5. So for the next step, you just want to either multiply straight across, or you can simplify and then multiply. When I say simplify, what I mean is this 2 and the 6, the numerator and denominator, will simplify. 2 goes into 2 one time. 2 goes into 6 3 times. And then you just want to multiply 71 times 3 and 1 times 5. And you end up with 213 over 5. The last step here is to rewrite that improper fraction as a mixed number. So 213 divided by 5 is 42 and 3/5. So the answer here is 42 and 3/5 square yards per hour. Problem number 3. The 3 times for 3 runners in 3 different races are given in the table. Which runner finished the race with the fastest kilometers per minute? So you can see here that we have runners A, B, and C, their distance, and the minutes. Here in our problem, it wants us to answer using the fastest kilometers per minute. So when we're looking at this, let's just compare the unit rates of these runners. And again, we're looking at kilometers per minute. I'm just going to shorthand that. So we have runner A, B, and C. The first runner, kilometers, is 5, and they ran in 34 minutes. B ran 10 kilometers in 62 minutes. And the last one ran 21 kilometers in 154 minutes. So let's go ahead and use a calculator to convert these. So the first one is 5/34. So you want to take 5 divided by 34, and you're going to get 0.147. Just take it out to the nearest thousandth. Next is 10 divided by 62, and that converts to 161,000th. And C is 21 divided by 154, and you get 136,000th. So when you're comparing these, because we've taken them, all three of them, out to the thousandth, we can see that this is the greater. So B is the fastest runner. If we think kilometers per hour or miles per hour, here the kilometers per minute, we're looking at the fastest speed as 161,000th. So runner B is the winner, or the fastest, we could say. Last question, number 4. So this question states, a dolphin can swim 1/5 of a mile in 20 seconds. How fast does it swim in miles per hour? Now notice here we have miles to miles, but seconds to hours, so we need to convert this, but we're going to have to do this at the same time. So we know that we are miles per hour, and set up this ratio. And we know it will swim 1/5 of a mile in 20 seconds. So we need to convert, let's go ahead and convert the seconds into a minute, which is going to be 60 seconds, we know is 1 minute. So how do we get from this 20 to the 60? Well, 2 times 3 is 6, so 20 times 3 is 60. And then we want to multiply this by 3, the 1/5. 1/5 times 3, well, remember this is just 3 over 1. Multiply your numerators together, you get a 3. Multiply your denominators, and you get a 5. So in 3/5 of a mile, the dolphin can swim 3/5 of a mile in 1 minute or 60 seconds. Next, so now we know what it swims in 1 minute, and this is just 1 unit rate that we have. We're then going to take and convert this into how many minutes in an hour? Well, there's 60. So let's just take this down here. So we have 3/5 of a mile it can swim in a minute. We need 60 minutes because we know that that's going to equal 1 hour. To get from 1 minute to 60, 1 times 60 is that 60. So we want to take 3/5 times 60. So let's take a moment and write this one out over here. I'm going to just make a little box. So we're going to take 3/5 times 60 over 1. And again here, we can simplify before we multiply, make it a little bit easier on ourselves. So 5 and 60 can simplify. 5 goes into 5 once, 5 goes into 60 12 times. So we know 1 times 1 is equal to 1. And then 3 times 12 is 36. So it can swim 36 miles in 60 minutes or 36 miles in 1 hour. So the dolphin actually swims 36 miles per hour. And it would be nice if we had done this in class, because I had a student Zoom with me today, and she did the simplifying here and then multiplied by 60. And then we also have to consider, well, we have to do that by 60 one more time, and we would still come out with the same answer of 36 if we did it that way. So I hope this helps. If you need any additional help, please come into the Zoom meetings, and either Miss Kathy or myself will help you out. Just look in the announcements for the times that we'll be meeting.